Well, how can you fit 12 GPUs in a single 1U 2-socket server? That sounds like a physical impossibility, and yet Liqid has done it. No, it's not Time Lord technology, it's not bigger on the inside, it's the Liqid Fabric. And the Think Tank is a second generation platform that brings us PCI Express composability. So I've got George Wagner here with me and Ben Bowles, and they're going to talk a little bit about what that means, because I think it's the future of infrastructure. It's the future of infrastructure as code. It's the future of companies being better able to manage their GPU resources, their FPGA resources, and making sure that they have higher utilization on their hardware. And higher utilization means better ROI. So if you work on these systems, or you're thinking about building these systems, or involved in IT at all, this is going to be of interest to you, because you don't have to be a Fortune 500 company now to take advantage of PCI Express switching fabrics. So welcome, Ben, George. Infrastructure challenges. Liqid's got a lot of customers in the Fortune 500, but if you've only got a maximum of 500 customers, that's not really super interesting. But these infrastructure challenges are challenges that a lot of companies face. What have you guys seen in your business experience?
First off, thanks for having us, Wendell. As we mentioned before, Ben and I both were in IT when we were younger kids, and the problems that we faced back then, which were the challenges of trying to fit resources into a box and trying to populate as many PCIe slots as possible on a server, is a challenge I faced back in the 1990s as well as the early 2000s, and they're very valid today.
Definitely dating yourself there.
Well, the gray hair didn't give it away. I don't know what would.
That's one of the things that I'm super excited about, because, listen, I've got I'm just, a very small operation here at Level 1 Techs, and I've got 2 Tesla V100s. And truth be told, the utilization on those is not quite as high as I would like, but the PCI Express Fabric, being able to basically software select which physical server they're attached to, depending on what job I'm doing, that's really exciting. And that's really one of the core promises of the Liqid Fabric.
Yeah, that absolutely is the magic right there. The ability to essentially extend the PCIe bus outside of a system, add software to actually compose those devices to any server that needs them is truly a groundbreaking technology, and we're really excited about it.
Now, tell me about customer use cases, because there's VDI, there's AI applications, Kubernetes. And it seems like GPU and FPGA accelerated workloads are, in vogue, whether you're a stealth mode startup or, just even a research organization.
So, great question. Today, I had the opportunity to give a webinar to a bunch of end users. And one of the questions I asked them on a poll was, what type of workloads are you using GPUs for today? And I listed out AI ML, I listed out HPC, virtualization, crypto mining, several of them. And believe it or not, the largest one I saw on the list was virtualization, but there was a smaller amount of, I would say it kind of went down to HPC, ML workloads, AI ML workloads, and I didn't see any on crypto mining. However, Ben and I have been very close to a couple of customers we have right now that are moving in that direction. So there's a ton of them, and I think we're learning more every day as to what we can solve, because there's a lot we just don't know.
So is it the situation where you literally don't have anything else to do with your resources? It's like, it's on anyway, let's just go ahead and crypto mine.
It's funny you should say that. So I had on this call I was on today, one of the folks who's on the call, they're either a customer or they're going to be a customer very soon. We're talking about running their daytime workloads and then at night doing crypto mining with Liqid. So
yeah, that's one of the really exciting use cases with this. And having worked with people that manage some very large VMware VDI infrastructure, they sort of lament that the infrastructure is built for basically peak utilization. So, during the day, the cluster of, a dozen, 24 servers or whatever is super busy, but most of the time it's really not that busy. And then you've got the researchers that are over and doing things with machine learning, and sometimes they're doing a job that could really benefit from a little bit more oomph. And this is the first product that I've seen that really, really competently gives you a way to script and control all that. You can have your physical ESXi hosts composed with physical GPUs running, grid or whatever, and that is your accelerated workload for your VMware side of things. But as the cluster gets less busy, you can shut down some of those hosts. You can decompose that GPU in software, move it over to a Linux machine, move it over to Kubernetes, move it over to something else for a CUDA workload, bring that back up. NVIDIA EGX, you guys have support for EGX out of the box. And all of this can be controlled from software. I mean, this is truly software-defined infrastructure. It's very exciting.
It is. Yeah. I mean, like I said, it's basically software-defined hardware, right? At the end of the day. And, I have these conversations with customers, I'm sure Ben does as well, where it takes a second for them to suspend disbelief while we explain to them what's actually happening, what's possible. And then once they get it, they're like, why haven't we been doing this the whole time? Well, there are reasons, right? There are technological reasons why it hasn't happened till now. But
yeah, you would have to physically have somebody in the data center take the GPU out of this box and put it in that box, or reboot the server or something crazy.
I have the scars to show digging into boxes when I was younger.
So ThinkTank, it's available in a couple of different sizes. 1 box, 2 box, 4 box, and over 9,000 watts for the 4 box solution, and that gives your servers, in a central rack sort of setup, access to not just GPUs. You can also do NVMe and NVMe over Fabric and FPGAs, right?
The whole premise around ThinkTank was to continue our journey on what we call CDI simplified. So bringing composable, disaggregated infrastructure and small, medium, large packages, even rack scale packages. So Wendell, you mentioned it's no longer confined to somebody who has millions of dollars to spend on infrastructure. This is something that customers can get going with, that with a much smaller appetite, and get going with CDI and be able to compose in GPUs, storage, FPGAs, if you mentioned, and be able to do that. And it's much more flexible and efficient at the end of the day.
Yeah, I've played around with some solutions for stuff like this that's kind of sort of in the cloud. And not only is it wildly expensive, it's nowhere near as flexible as what the promise of this is, because literally I could write a shell script that, shuts down physical machines and adds PCIe resources, or hot plugs PCIe resources if the software supports it, and will move physical hardware around. And there's not really overhead. It's not like you have a virtual machine where you do PCI Express pass-through. That's a really popular topic on the Level 1 channel. This is a truly switched PCI Express fabric. So the PCI Express fabric from one host, it's not going to another host. You're not bottlenecking. There's no bandwidth problem there. So it's really kind of exciting that you can do this at a software level. It is truly defined software infrastructure, even if your infrastructure needs special sauce hardware.
Yeah, that's right. I mean, when you get down to it, what we've done here at Liqid and then the special sauces and what our software, we call it the Liqid Matrix software. And that's what is performing the programming of the PCI Fabric. And then that's how the devices then end up being composed into the bare metal servers, as you mentioned. And then on top of those servers, customers can run their bare metal workloads. They can run virtualized workloads with, VMware or a KVM hypervisor, as well as we're seeing more and more, containerized applications and workloads. And so they can compose in the resources they need when they need them. And then when they're done, they can move them back out to the free pool, and those can be utilized for other applications, other workloads. So that's, some of the easy ways that we're able to drive up the efficiency and in environments for customers, and so real world applications that we're seeing over and over, that they come back and say, hey, I've been able to, double or triple the utilization of my GPUs just simply by, layering in the Liqid technology.
A new thing that's been kind of hot is also PCI Express peer-to-peer communication. And in one of the demos that I did with you guys a couple of weeks ago, I was very impressed because I didn't expect IOMMU and PCI Express peer-to-peer communication to be handled correctly, but it is actually that's also programmable on the Fabric. Can you speak a little bit to that and the kind of workloads that it enables?
Sure, absolutely. Yeah, that we're excited about that technology that we call the feature in our product. We call that IO Direct, peer-to-peer. And so that enables on the PCIe Fabric, we can create the channels between the different devices across the PCIe Fabric. And that way, those devices don't actually have to go up to the CPU complex to communicate with each other. And so the two areas that we're seeing, adoption right now is in GPU to GPU communications over peer-to-peer. And then an emerging one is GPU to NVMe storage. So because the GPU and the NVMe devices exist on the same PCIe Fabric, they can communicate directly to each other. And that the NVIDIA flavor of that is called GDS, or GPU Direct Storage.
Yeah, this is really exciting because it dramatically lowers the amount of CPU overhead required to do a lot of jobs on the one side. And on the other side, there are a lot of really impressive demos that different vendors are doing out there that basically let your horde of 12 GPUs or 20 GPUs or the entire rack of GPUs function logically as one GPU instead of having your working set duplicated in the VRAM of all the GPUs. One of the GPUs can just pop up and say, hey, who has this block? And it's a GPU over here. It can go get it out of that GPU's VRAM. Everybody's happy. And the CPU has no idea what's going on, which is great.
Yeah, I think some of the early returns on our that we're seeing is, an order of magnitude increase in performance and reduction in latency by doing the peer-to-peer and the IO Direct within the Liqid Fabric versus having to involve the CPU complex and all of those operations.
Yeah, so this platform, this second generation platform, would be an excellent starting point for any team that needs to explore those options, I think, then, wouldn't you say?
Yeah, absolutely. And now that we, with Think Tank, we have it packaged into, something that nearly any customer considering GPU workloads, can get access to in an affordable manner. And so, compared to, what we've been doing in the past with, just stuffing, GPUs into servers, we started with kind of your more traditional servers, and now there's, vendors out there that are doing, I call them GPU optimized servers, where you might be able to get, 4 GPUs into a single server, maybe even up to 8. We can really enable configurations that, just like you started off, that aren't possible with your traditional servers, where we can have upwards of 16, even 20 GPUs connected to a single server.
20 GPUs in a 1U server, it really is bigger on the inside.
I know. So it it definitely enables workloads, like you mentioned. Where say you're a researcher and you want to have a workload that spans, 16 GPUs. Up to this point, that's just not possible if you go down the traditional server route.
Yeah, from a system administration standpoint, I'm thinking about, cost savings for the enterprise. And let's say that you're, in a 150 employee company, and you've got a couple of these, during the day, most of your GPU resources are dedicated to VDI. You might only have 2 GPUs allocated to the physical machines that your research team is using. But then, toward the end of the day, you might only need 1 or 2, probably 2 or 3 servers in that VDI cluster. You can draw down all of the other nodes and then reassign the GPUs for research and let that run for 16, 14 hours a day. And your research team will be real happy. I mean, they're able to do research during the day, but at night they can, really see their job take off and get a ton more resources. That's a huge cost savings for the company because they're not having to buy tons and tons of $5,000 GPUs. I mean, every GPU that you don't have to buy is literally a $5,000 savings.
Yeah, it's been a pretty straightforward thing to be able to describe to our customers, and they get it right away about, look, if you could, increase the utilization on one of the most expensive resources in your environment in a GPU, and go from, a lot of them say, sub 20% utilization is what they're getting today. If you could increase that to, 40, 50, even north of 70% utilization that we've seen some of our customers achieve, I mean, that's the return on investment, the TCO calculations just fall out from there.
Yeah, I would also emphasize that having your team build and structure everything as infrastructure as code, there's so many things that you get out of that for free. Really amazing disaster recovery. You've defined your infrastructure in code. You know where your physical machines are. You know what resources your physical machines need, how much RAM, how much storage, what kind of connection the storage has, what sort of GPU resources. You know what you need in terms of backup because you've specified that in terms of your infrastructure as code. And then, oh no, disaster strikes. You don't have to have something that's lovingly handcrafted by your brilliant system administrators, your underappreciated computer janitors. No, you just literally have an XML file somewhere that defines your infrastructure. You import it into that and you're good to go. Or you need to seamlessly transition from local infrastructure, the edge, to the cloud. I mean, this is absolutely the future, infrastructure as code, because nobody wants to do, the special lovingly handcrafted servers anymore. You just want to define it in software. And this is literally that for all of the edge cases that didn't work with virtualization and containers up till now. FPGAs, GPUs, NVMe, NVMe over Fabric. You literally define a policy and say, I want this machine to have this level of IOPS and this level of CUDA resources, and you're good to go. And I'm sitting here thinking, this is going to make me sleep better at night because I don't have to worry about horrible things happening in the data center or at the edge. As long as I've got the block of data and the definition for the infrastructure, I can hit a button and I've got that infrastructure somewhere else. That's amazing. That's just truly breathtakingly amazing that we're finally there and that it's finally a commodity.
Yeah, it's interesting to think about the words that you use there, where you're basically describing bare metal servers that are defined in software.
Yeah.
And so, and then, you take our API that, rich API that we have and, plugins into workload managers like Slurm or, management, like a vCenter plugin that we have. And so then, you're beginning to drive that from the requesters or the tools that that our customers are accustomed to using. So, that added, software interface is really what's been missing.
Yeah, and Liqid, it goes without saying that Liqid's solution is fully supported and fully integrated and fully sanctioned, I guess, by VMware. It is a fully ready-to-go VMware plugin. If you need to compose hardware in and out of your cluster, you totally can do it. VMware is a little squirrely when it comes to PCI Express hot plug. They want to support NVMe, and that's coming and some other stuff. But like I say, in a cluster, you can move your virtual machines and draw down nodes in your infrastructure and still handle that via script. There's better things on the horizon. But if you're an existing VMware infrastructure and you think you can't do this because you've been told in the past you can't do this, you totally can do this. I've seen it done. OMG.
Yeah, no, that's a good point. I mean, not only do we have a vCenter plugin, we have support for technology like SRIOV, which is required to support, vGPU and things of that nature. So, we have a lot of customers that have deployed virtualization on top of our, Liqid Matrix technology and are getting really, really good results.
What does a deployment of the think tank look like at this point? Just call up Liqid and the rack arrives and you're good to go, or how does that? What are the logistics here?
Yeah, the idea is that it's a turnkey system. So we're calling it a composable system, and it includes all the software, all the hardware and support that a customer needs, and pre-integrated, pre-qualified, all the proper cabling and things of that nature. And so a typical deployment, probably, get up and running and have be able to compose probably in about half a day kind of a thing. And so it's tailored for those customers that want to get into the software defined and the composable infrastructure and get the benefits of what we just talked about.
Yeah, that's huge. I mean, being able to hand it to the programmers and the dev team, and it's like, here's your interface, here's the box, it's got the hardware in it, let's figure this out.
Right.
It's also nice from a management standpoint. So like if I'm managing a dev team and the dev team comes to me and I'm looking at the spec sheet for this amazing new thing that's going to transform the amount of money the company's making, But I'm reading the requirements here, and it basically translates as the moon. I could deploy something like that on this and get actual real world metrics for the physical hardware. I mean, as far as they know, they've got a physical box with the physical stuff installed in it, and the performance characteristics and the PCI Express and everything that they're used to is a physical machine. It's not a virtual machine. But using Liqid's tools, I can look at it and I can say, okay, here's some info about the utilization. Here's some of the stuff that I see across the fabric. Here's some of the other stuff. As an administrator managing the people with stars in their eyes, I can see, okay, this is how much they're actually using their infrastructure. And I can sort of oversubscribe some of that infrastructure in the various ways that we can oversubscribe different kinds of hardware. And so that's also huge in terms of maximizing utilization in a way that doesn't make those guys nervous.
Yeah, no doubt. I mean, at the end of the day, what we're doing is, disaggregating the resources out into pools and then composing them into the bare metal servers. And so, whether it's the applications or the management interfaces or management tools, if you want to, get at those resources, they look exactly like they would be installed into the server. So if you want to get utilization rates or performance metrics or, things of that nature, it all is going to look exactly like it was installed in the physical server.
So we're talking in hypotheticals. What about real customer experiences? We were talking before, and you had some pretty amazing stories about customers that had consolidated dramatically in their upgrade cycle because they took a chance on going the fabric route because it's kind of alluring. You've got some stuff. There's some pamphlets. I want to subscribe to your newsletter.
Absolutely, yeah. So, yeah, one of the stories I like telling is we do have a customer of ours who had a challenge in that he had multiple dev teams, and those dev teams had larger kind of GPU optimized boxes, and those could hold several GPUs. However, when he'd assign those GPUs to those various groups, they'd often sit there idle, not being used.
Yeah, and so they were at basically the end of the life for this set, and they were trying to figure out what to do. It's like, we got like 4 or 5 year old servers. What do we do next? And it's like, does Fabric make sense?
Well, so this is interesting, right? So he ended up not only freeing the GPU from the servers, right, but those servers were no longer these large, beefy servers that had to hold GPUs. Right, he was able to get smaller servers, lighter servers, lower power servers, lower footprint servers, and not only that, he didn't require as many GPUs, so he's able to utilize them better. So one of the things he told Ben and I was like, "It's like I'm getting my GPUs for free." Right, so it was beneficial not only from a business standpoint because they were able to deliver the results they needed with the hardware, the GPU resources demanded, but they were also able to, reduce their footprint, reduce power, et cetera. So it was like a complete win-win.
Yeah, and it's easy to imagine, the logistics of that from the researchers that actually use them. It's like, oh, we had 7 boxes that had GPUs, and it's like, okay, 2 people were fighting over the same box, or maybe we software reconfigured that. And from an administration point, that kind of thing is always like a headache unless you're dealing with like containers and VMs, right, stuff like CUDA. But this isn't that. This is physical machines. Those guys, you can just give them a physical machine, and they might have an SRIOV GPU mapped through there. So it's a slice of a GPU. And you can give them a bigger slice or a little slice, or you can give them real physical hardware. You can look at it and say, well, they're not really doing much with the GPU right now. Let's swap that out. Let's switch their regular for decaf and see if they notice. And it's like, oh, this is only a tiny SRIOV slice of a GPU, but they're not doing anything right now anyway, so it's fine.
Well, one of the things, so as you're saying that, Wendell, that kind of also plays to the cost savings around, from an operations standpoint. Imagine having to do all of that physically, right, versus doing it all with software. So you get, it's definitely multiple angles, whether it's the flexibility, kind of the agility of moving things around, and also the efficiency. That efficiency is from a capital standpoint, as I was just mentioning, but it's also operational. So it's a pretty interesting story.
Yeah, it's easy to imagine, in that story, it sounded like they consolidated multiple racks of equipment down to basically a single rack equivalent. You get less heat output, less energy usage, higher utilization on the equipment that you have, but higher utilization on the equipment that you have is ideal. It gives you a much better indicator of when you need to buy more hardware and how you need to grow. but also your infrastructure is generic. So when you need to buy more infrastructure, it's not, a fire-breathing behemoth box that's got 7 GPUs in it. It's like, oh, that box is down. And it's like, it doesn't matter. Just, reallocate those GPUs somewhere else. So, that's good. It's more space in the data center and less energy use.
And also, when it's time to scale, you're scaling. I'm sorry, it's time to scale. When it's time to add additional boxes, additional servers, when it's time to grow, you're kind of growing asymmetrically versus having to buy everything all at once in a box.
Yeah.
I go from V100s to A100s. I simply compose out the V100s, add the A100s. Right? I don't have to buy
it's a
another
software thing, yeah.
It's a software thing. You wouldn't understand. So.
Yeah, actually, that's funny. I was helping there was somebody on our forum the other day that was doing some FP64 work, and they had an A40, and it was a university, and something like that would have been amazing if you could just go your administrator and say, okay, most of the job that I'm doing is usually TensorFlow, that runs great on A40. I really have this other job that requires floating point 64. I need an A100. You could just go on the Fabric, and if that's in the pool, click, done. The guy, it's a 3 seconds of work to do that and give that person access to an A100. And then when they're done with that job, decompose it out and give them back their A40, which is fine most of the time for what they're doing.
Exactly.
Well, we talked a lot about, NVIDIA and EGX and their support, but this is also fully qualified for ROCm and AMD solution as well. And I think that's worth mentioning because some researchers are very deeply ingrained in the ROCm ecosystem, and this is fully supported there, including the GPU to GPU communication and all the fancy stuff that AMD's got going on there.
Yeah, one of the really interesting things that we've done here with Think Tank is it's qualified for not only the NVIDIA Ampere GPU family, but also the AMD MI100 and soon to be some of the newer MI200 class GPUs. And a really important part of what we're doing at Think Tank is to have the software stack support. So the AMD ROCm, stack runs on the Think Tank, fully supported, and we've worked closely with AMD to optimize that and make sure that it performs really well, things of that nature.
That's awesome. Basically, it doesn't matter what kind of research scientist you are. If you're working at Oak Ridge and you would like a home setup, you can just in a couple of clicks deploy this and be able to run it on your Think Tank mini cluster, as well as, the supercomputer that is the ROCm monster at Oak Ridge. Yeah, whatever. That is the Liqid Think Tank. And it gives you programmable, expandable, disaggregated PCI Express infrastructure, whatever your PCI Express devices are. There's a long list of qualified devices. Liqid's got all kinds of info on that. I'm really excited about this because this is the future. PCI Express was originally invented to be a server-to-server communication protocol. And here it is, finally, how many years later? This is what it has always been designed to do, and to be able to see it accessible to, average Joe folks and not just the Fortune 500 in the Think Tank product is really exciting to me, which is why I wanted to have Liqid on. So, George, Ben, thank you very much for joining me.
Thank you, Wendell. Great interview.
Thank you, Wendell.
And if you want to learn more about it, check out the Liqid website. But yes, PCI Express, being able to specify this is the future. It's absolutely the future because it's software-defined infrastructure, no matter what your infrastructure is. So yeah, I'm excited. I'm Wendell. This is Level 1. I'm signing out. And you can find me in the forums. I don't know if you like this, if you think this would be a good fit. Let's chat. Because whether you're in education or research or higher enterprise, probably can use this.